Imagine your entire primary data center just went completely offline, like a total blackout.
Oh, wow. Yeah, that is a nightmare scenario.
Right. Sirens are probably going off in the building. People are totally panicking. But if you designed your VMware Cloud Foundation architecture correctly, your workloads didn't even blink.
It just kept running.
Exactly. Welcome to this deep dive. Today, we aren't just, memorizing a list of exam questions. We are figuring out how to build unbreakable intelligent systems.
Because that is the ultimate goal, really.
Yeah.
Moving away from just plugging in servers and moving toward, well, orchestrating a self-managing cloud.
Yeah, exactly. And to prove you can do that, you have to pass the exam. So we are going to help you master the practice questions for the VMware certification exam.
It's definitely a challenging one.
It is. And for you listening, if you are looking for the exact code, we are focusing on the exam coded exactly as 2V0-17.25.
Yeah, and that specific exam really forces you to abandon the old component mindset.
Right.
You cannot just know what a single piece of software does in isolation anymore. You have to know the underlying logic of how it orchestrates with the entire stack.
Which is why we definitely have our work cut out for us today. The source text breaks this exam down into 4 distinct sections.
Section 1 covers IT architectures, technologies, and standards, right?
Yep, that's the one. Then Section 2 gets into VMware Cloud Foundation, which we'll just call VCF for short. That covers the fundamentals.
Okay, got it.
Then Section 3 is all about how to plan and design the VMware by Broadcom solution. And finally, Section 4 covers how to deploy, configure, and operate VCF.
So it really covers the whole life cycle.
It really does. Okay, let's unpack this. We are going to dive straight into these practice questions, but we are making a promise to you right now.
We are going to read you the questions and the options, sure. But we aren't just handing you an answer key.
No way. We are going to break down the fundamental why behind every single option so you truly understand the mechanics.
Right, because when you understand the mechanics, you don't have to rely on rote memorization. The answers just become logical.
Let's test that logic with the absolute foundation of setting up VCF. I'll read question 1.
Go for it.
It says, which VCF component relies on application virtual networks being configured and routable before deployment can begin from the SDDC Manager?
Okay, and what are the options?
The 4 options are A, VMware NSX Manager Cluster, B, VMware vCenter Server, C, Area Suite Lifecycle, or D, vSAN Stretched Cluster Witness.
Right.
Now, my old school IT instinct instantly says vCenter Server, option B. Because it feels like vCenter needs the network ready before anything else. Am I falling into a trap here?
You are definitely falling into a trap.
Yeah, I knew it.
Yeah, the correct answer is actually C, Area Suite Lifecycle.
Okay, wait, why Area?
Well, to understand why your instinct was wrong, we have to look at what Area Suite Lifecycle actually does during initial provisioning. It deploys a whole suite of management tools that instantly require predefined, segregated network spaces to talk to each other and the outside world.
Oh, I see.
And those predefined spaces are the application virtual networks, or AVNs.
So the AVNs are essentially like the pre-laid digital plumbing.
Yes, exactly. But more specifically, they are routed overlay networks. If those AVNs are not pre-configured and routable, the automated deployment workflow from the SDDC Manager simply stalls out.
Because it literally has nowhere to put the area components.
Right. Now let's look at why the other options are incorrect.
Yeah, what about NSX and vCenter?
Well, option A, the NSX Manager Cluster, and option B, vCenter Server, are actually the infrastructure that creates the environment where AVNs can exist in the first place.
Oh, so they come first.
Exactly. They are deployed earlier in the bring-up process using standard management networks, not AVNs.
Okay, that makes total sense. You have to build the factory before you can use the assembly line.
That's a great way to look at it.
And what about option D, the vSAN Stretched Cluster Witness?
That fails because the witness is typically an external appliance used for disaster recovery configurations, which happens way later.
Right.
It relies on standard routing to the vSAN network, not the specific AVN overlay designed for the area management suite.
Got it. So now that we have our components deployed, what happens when it's time to upgrade them?
That is the logical next step.
And that brings us to question 2. It asks, when performing a sequential upgrade of a VMware Cloud Foundation environment, which component must be upgraded first before the others can proceed?
Okay, let's hear the options.
Your options are A, VMware vCenter Server, B, SDDC Manager, C, VMware NSX, or D, VMware ESX hosts.
I'm sure.
Now, since SDDC Manager deployed everything, does it also lead the upgrades?
It absolutely does.
Yeah.
The answer is B, the SDDC Manager.
Makes sense.
Yeah. In VCF, the SDDC Manager is the orchestration engine. It holds all the logic for the entire lifecycle management of the environment.
So why can't I just go patch an ESX a host if there's like a critical security flaw? Why is option D wrong?
Because if you upgrade an ESXi host or vCenter or NSX first options A, C, and D, you are upgrading the agents before you upgrade the brain that manages them.
Ah, great.
The SDDC Manager contains the validated compatibility matrix. It knows exactly which versions of vCenter work with which versions of NSX.
So if I upgrade vCenter on my own,
If you manually upgrade vCenter behind the SDDC Manager's back, the SDDC Manager might lose its ability to communicate with vCenter and your automation completely breaks.
wow, okay. That is a critical mechanism to understand. The brain has to be upgraded first so it knows how to process the new capabilities of the body.
Exactly.
But, software upgrades rely on having the right hardware foundation. Let's talk about storage hardware with question 3.
Okay, hit me.
It reads, an administrator is planning to implement VS Express storage architecture for a new workload domain cluster. What is a strict hardware requirement for the nodes participating in this cluster? Options are A, mixed solid-state drives and hard disk drives, B, NVMe-based flash drives exclusively, C, fiber channel host bus adapters, or D, dedicated physical hardware RAID controllers.
The correct choice here is B, NVMe-based flash drives exclusively.
Oh, exclusively.
Yeah, exclusively. The vSAN Express Storage Architecture, or ESA, was built from the ground up to eliminate the bottlenecks of legacy storage.
I bet a lot of people taking this exam might assume you can just mix solid-state drives with traditional hard drives to save money.
Oh, definitely.
Why is option A a massive mistake in modern VCF?
Because ESA completely ditches the traditional concept of disk groups, where you had a cache drive fronting slower capacity drives.
Right.
It relied on a single tier of uniform, incredibly high-speed storage media. If you introduce a spinning hard disk, you destroy the optimized data path. It simply is not supported.
And what about option D? Why does a dedicated physical hardware RAID controller violate the architecture? Doesn't hardware RAID usually make things faster?
Well, not anymore. Not with this setup. ESA is designed to handle all the RAID processing and data protection in software right at the hypervisor level.
Oh, I see.
If you put a physical hardware RAID controller in the middle, you are essentially putting a physical traffic cop on an automated, high-speed digital highway.
That is a great analogy.
Thanks. Yeah, the physical controller just becomes a bottleneck and masks the true state of the drives from vSAN.
And I'm guessing that's why option C, fiber channel adapters, is wrong too.
Exactly. Fiber channel is for legacy storage area networks, not software-defined NVMe storage running locally on the nodes.
It really is a totally different paradigm. You are stripping away the legacy hardware managers and letting the hypervisor handle it all at blinding speeds.
Exactly.
Now, before you can utilize those screaming fast NVMe nodes, you have to bring that raw hardware into the system. Let's look at question 4.
All right, let's hear it.
Before commissioning new unassigned hosts into the SDDC Manager inventory, an administrator must ensure a specific network configuration is prepared. Which configuration is required to handle traffic for the newly commissioned hosts?
And the options.
Options are A, a dedicated network pool, B, a pre-configured gateway, C, a static routing protocol, or D, a global distributed port group.
What's fascinating here is how VCF strips away the manual configuration we used to really dread.
Yeah.
The answer is A, a dedicated network pool. Before you can add a host, you define this pool inside SDDC Manager.
Okay, what's in the pool?
It contains the IP address ranges, the VLAN IDs, the subnet masks, basically everything a host needs to identify itself on the management network.
Let me push back on that for a second, though. If I just need to hand out IP addresses, why can't I just use a standard DHCP server?
I get that question a lot.
Yeah, why go through the trouble of a dedicated network pool?
Because standard DHCP is dynamic and can be unpredictable. When SDDC Manager brings a physical host into the inventory, it needs absolute deterministic control over that host's identity.
So it's about control.
Exactly. The network pool allows the SDDC Manager to statically and permanently assign those parameters during the commissioning workflow, so they never change unexpectedly.
Ah, so it's about deterministic automation. Let's look at the wrong answers then. Why not a pre-configured gateway, option B?
Well, a gateway just routes traffic off the subnet. It doesn't assign identity to the host.
Okay, and C?
Option C, A static routing protocol is also wrong because routing protocols govern network paths, not host provisioning.
And D, the global distributed port group.
That is something that gets configured after the host is commissioned and added to a cluster to handle virtual machine traffic. It doesn't handle the physical host's initial arrival.
Fantastic breakdown. So our hosts are commissioned. They have their identities. Now we have to build the environment. Question 5 asks, a new VMware Cloud Foundation deployment has just completed the bring-up process. Which two components are strictly deployed within the management domain by default? Choose two.
Okay, 2 answers.
Options are A, SDDC Manager, B, tenant workload virtual machines, C, NSX Edge Clusters for user traffic, D, VMware vCenter server for the management environment, or E, Horizon connection servers.
All right, what do you think?
Well, okay, based on our conversation so far, SDDC Manager is the brain, so A has to be one of them.
Yeah.
And D, the management vCenter server, seems pretty obvious.
Spot on. The correct answers are A and D. The very first thing VCF builds is the management domain.
Okay.
It is a dedicated, ring-fenced cluster of hosts that only runs the infrastructure needed to manage the rest of the cloud.
So it's a strict separation of duties.
Exactly. And that explains why the other options are completely wrong. Option B, tenant workload VMs, and option E, Horizon connection servers for virtual desktops, are the actual payloads.
Right, the stuff people actually use.
Yeah, they belong in workload domains, which you spin up later.
Yeah.
You never mix user workloads with your core management tools.
And option C, the NSX Edge Clusters.
Those are for user traffic, so they also belong in the workload domains to handle the routing for those specific user apps.
You keep the control room totally separate from the factory floor.
Exactly.
Which leads us nicely to question 6, because once that control room is built, it has to be locked down tightly.
Security is key.
Yep. An organization requires regular password rotation for all infrastructure appliances, which VMware Cloud Foundation tool provides a centralized interface to manage and rotate passwords for components like NSX Manager and vCenter server.
Options.
Options are A, Identity Manager, B, SDDC Manager, C, ARIA Operations for Logs, or D, vSphere Client.
We are seeing the pattern again here. The answer is B, SDDC Manager.
SDDC Manager again.
Yep. It isn't just an installer. It acts as the centralized credential manager. You can set policies within SDDC Manager to automatically reach out to vCenter, NSX, and ESXi hosts and rotate their passwords on a schedule.
I have to ask, though, isn't the SDDC Manager getting a little too much power?
How do you mean?
I mean, it handles the initial network deployment, it dictates the upgrade order, and now it holds the keys to all the passwords. If that thing goes down, aren't you in major trouble?
That is a very common reaction, but if we connect this to the bigger picture, centralizing this power solves a much worse problem, which is configuration drift.
Okay, walk me through that.
Imagine a team of administrators manually logging into 50 different ESXi hosts and 3 different vCenter servers to update root passwords.
Oh, man.
Someone makes a typo, someone forgets a server. Suddenly, parts of your infrastructure can't authenticate with each other, and you have a catastrophic outage that takes days to troubleshoot.
Yeah, that sounds awful.
By making SDDC Manager the single source of truth, you eliminate that manual human error.
Okay, I see. It removes the human variable from routine security. And the other options.
Option A, Identity Manager, is for user single sign-on, not automated service account rotation. Option C, Area Operations for Logs, just collect syslog data. It obviously doesn't change passwords.
Right, and D.
Option D, the vSphere Client, is just a UI to manage vCenter. It doesn't orchestrate passwords across the entire VCF stack.
Okay, let's pivot from internal security to how we reach the outside world. Question 7 is a bit of a beast.
Let's hear it.
An administrator needs to deploy an NSX Edge Cluster through SDDC Manager to support external connectivity for a workload domain. Which 3 prerequisites must be established in the environment prior to this deployment? Choose 3.
Okay, 3 right answers here.
The options are A, 2 different virtual local area networks for uplink traffic, B, border gateway protocol routing established on the physical switches, C, high availability mode set to active standby,
Okay, keep going.
D, dedicated physical network interface cards for the Edge virtual machines, E, a virtual local area network for Edge overlay traffic, or F, IPsec virtual private network tunnels.
Wow, okay. This one really separates the novices from the architects. The 3 correct answers are A, B, and E.
Okay, let's walk through the mechanism.
Well, to deploy an NSX Edge Cluster, You are building the bridge between your virtual networks and your physical data center network.
Right.
To do that, you need two physical paths for redundancy, which means option A is correct. Two different VLANs for uplink traffic.
Makes sense.
Next, option B, Border Gateway Protocol, or BGP, must be configured on your physical switches.
Oh, here's where it gets really interesting. This is the moment the virtual environment forces a formal handshake with the physical hardware.
Exactly. BGP is the protocol they use to dynamically share routing tables. If the physical switches aren't speaking BGP, the NSX Edge has no way to advertise the virtual networks to the rest of the company.
Wow, okay. And the third one?
Finally, option E is correct. You need a VLAN for edge overlay traffic. This is specifically to carry the generative tunnel traffic between the edge nodes and the host hypervisors.
Wait, hold on. Let me stop you right there. Generative tunnel traffic. For the listener who hasn't configured an overlay in a while, what exactly is happening inside that tunnel?
That's a great question.
Yeah.
So Generative is an encapsulation protocol. It takes the virtual layer 2 network traffic from your VMs, wraps it up inside a standard layer 3 UDP packet, and shoots it across the physical network.
Oh, like putting a letter inside a bigger envelope.
Exactly. The physical network just sees a standard UDP packet. But when it hits the other side, NSX unwraps it, and the VMs think they are sitting on the same local switch.
That is wild.
And the Edge Overlay VLAN is the dedicated physical highway for those wrapped up packets.
That makes perfect sense.
Right.
Now, why are C, D, and F wrong?
Option C, Active Standby HA, isn't a prerequisite. You often deploy edges in active mode for better throughput.
Okay.
Option D, dedicated physical NICs for the Edge VMs, is wrong because the Edge VMs run on top of the standard host networking. They share the host's physical NICs. Option F, IPsec VPNs, is a surface you might configure after the Edge is built, not a prerequisite to building it.
Got it. Network routing isn't the only thing needed for communication, though. You also need cryptographic trust.
Oh, absolutely. Certificates.
Question 8. A security audit indicates that self-signed certificates in the VMware Cloud Foundation environment must be replaced with enterprise-signed certificates. Where should the administrator initiate the automated certificate replacement process for the core management components?
And the options.
Options are A, vCenter Server Appliance Management Interface, B, NSX Manager User Interface, C, SDDC Manager, or D, RE Suite Lifecycle.
If you've been following the logic of this episode, the answer should jump right out at you. It is C, SDDC Manager.
The single source of truth strikes again.
Precisely. SDDC Manager automates the generation of certificate signing requests, and once you get the signed certs back from your enterprise authority, SDDC Manager automatically distributes and applies them to vCenter, NSX, and the ESXi hosts.
Okay, what happens if an administrator decides to be a hero and just logs directly into vCenter option A to install the certificate manually?
They will break the environment.
Seriously?
Oh, yeah. If you bypass SDDC Manager, its internal database becomes out of sync with the actual state of vCenter. The next time SDDC Manager tries to perform an automated upgrade or rotate a password, the certificate validation will fail and the automation crashes.
Oh.
That's why options A, B, and D are dangerously incorrect. You must use the central orchestrator.
All right, let's transition from management and trust back to daily workload operations. What happens when your compute is fine, but your storage is running dry?
A classic problem.
Question 9 asks, after deploying a workload domain with vSAN as the principal storage, the storage capacity is running low, but compute resources are abundant. Which two storage options can the administrator add as supplemental storage to the existing cluster? Choose two.
Okay, two choices.
Options are A, network file system data stores, B, direct attached mechanical local storage, C, virtual volumes, D, cloud native object storage, or E, tape library data stores.
The two correct answers here are A, network file system or NFS data stores, and C, virtual volumes, commonly known as vVols.
Okay, why those two?
Well, VCF recognizes that vSAN is your primary high-performance storage, but it allows you to cleanly mount external NFS arrays or vVols to the host to absorb extra capacity needs.
Oh, so you don't have to buy more expensive compute nodes just to get their drives.
Exactly.
Why not just go buy some cheap hard drives and shove them into the existing servers, though? Why is option B, direct attached mechanical local storage, incorrect?
because direct attached drives don't pool across the cluster natively unless they are claimed by vSAN.
Right, and we already established in question 3 that modern vSAN ESA doesn't support mechanical drives.
Exactly. Furthermore, you can't just have rogue local drives sitting outside the shared storage architecture. You lose high availability. If a host dies, the VMs on that local drive die with it.
Got it. What about D and E?
Option D, cloud-native object storage, like an S3 bucket, is fantastic for application-level data drops or backups. But ESXi cannot natively run a virtual machine's active disk file from an object store. It needs block or file storage.
And E-tape libraries?
Well, those are strictly for offline, long-term archival.
Yeah.
You definitely aren't running live VMs off magnetic tape.
Yeah, unless you want a latency of like 3 hours.
Yeah, exactly.
Okay, adding storage is great, but what if you need that storage to survive our blackout scenario from the very beginning of the deep dive?
Disaster recovery.
That brings us to question 10. To provide high availability across 2 physical data centers, an administrator is designing a vSAN stretched cluster for a workload domain. Which 2 conditions must be met for the vSAN stretched cluster deployment in VMware Cloud Foundation? Choose 2.
All right, let's hear the final options.
Options are A, the latency between the 2 primary data sites must exceed 20 milliseconds. B, the witness host must be located in a third independent site. C, both data sites must reside in the same physical rack. D, a stretched Layer 2 network is required for the vMotion network across sites. Or E, the management domain must also be stretched before the workload domain.
The correct answers are B and D. Let's look at the mechanism of option B first.
The witness host must be located in a third independent site.
Right. This is all about preventing a split brain scenario.
Wait, split brain? Let me see if I can visualize this. Imagine our 2 data centers are 2 separate islands.
Okay, I like it.
They are constantly syncing their data. Suddenly, the underwater cable connecting them gets cut. Both islands are perfectly fine, but they can't talk to each other.
Right. And if they can't talk, both islands might assume the other one sank. So they both try to take active control of the storage, writing different data to the same virtual machines.
Oh, that's bad.
Yeah, when the cable is fixed, the data's completely corrupted.
So the witness host in the third site is basically a guy on a third island with a satellite phone. When the cable gets cut, the 2 main islands call the third island. The island that gets the tie-breaking vote from the witness stays active, and the other one safely shuts down its storage access.
That is perfect analogy. It really is a quorum system. The third site provides the tiebreaker to prevent split brain corruption.
And the second requirement, D.
Right, D, a stretched Layer 2 network for vMotion. When a disaster strikes, or even during maintenance, VMs need to seamlessly migrate from Site 1 to Site 2.
Yeah.
If the network isn't stretched, the VM would have to change its IP address when it arrives at the new site, which drops active connections.
It just completely breaks the application.
Exactly. Stretching Layer 2 ensures the VM wakes up in the new data center, keeps the exact same IP, and the user never knows anything happened.
That's incredible. Now let's quickly eliminate the incorrect options for this last one.
Sure. Option A is backwards. Latency must be exceptionally low, typically under 5 milliseconds, definitely not exceeding 20. Option C defeats the entire purpose of disaster recovery. I mean, if both sites are in the same physical rack, a single power failure takes down the whole stretched cluster.
That makes sense. And option E.
Option E is a VCF-specific rule. You are not required to stretch your management domain just because you want to stretch a workload domain. They are decoupled.
Thank you for joining us on this deep dive. Good luck studying, and we know you're going to ace your exam.